This is for section 9.2. We're writing equations for parabolas. This equation is a little bit different than the parabolas we did at the beginning of the year, or that you may have done in Algebra 1. We're used to y equals an a value x squared. This is our typical way that we write a parabola. And it has a vertex at 0, 0. It has an axis of symmetry, which is x equals 0, which is your y-axis. Any point on the parabola is going to be equal distance from a focus point and a line called the directrix. If you look here at the picture, here would be a vertex. There's this point called the focus, and it's not the vertex. It's in between, always inside the curve. So that's your focus. You have a directrix, which is equal distance away. This is your focus point. And every point along this parabola is equal distance from both of these locations. So if you measure 1 unit away, you're going to measure 1 unit away to get to the directrix. If you measure 2 units, you're going to measure 2 units to get to the directrix. However far you measure, you always measure perpendicularly to the directrix, and it keeps making all the points that are the same distance away from the focus and the directrix. So we're going to look at a different way to write the equation. We're going to say x squared equals 4py. And this is going to make our parabola open up or down. And the way I like to remember this is it's x squared. You've worked with x squareds in the past. X squareds is a parabola, as you know it, and it opens up or can open down. So x squared will always open up or down. We could also, what's really new for us this time, is to have it written as y squared equals 4px. Y squared is nothing like we've had before. So, in fact, the parabolas that we'll be drawing here aren't functions. They open up to the right or to the left. A vertical line test shows that one x value gives you 2 y values. The equation x squared equals 4py will have a focus point that is up. So it's 0 right and left and p up. The directrix is always the opposite direction. So that's going to be a y value. And it's going to be the opposite of your p. So if your focus point was at 0, 3, your directrix line is going to be y equals -3. Your axis of symmetry is going to be x equals 0. Y squared equals 4px. This is opening right and left, so our focus point is moving right or left. So it has to be the x value. Therefore, the directrix is going to head up or down, and it's always going to be the opposite. So if p happened to be a negative number, like -4, 0, then your directrix would be x equals +4, because you always change the sign. And your axis of symmetry, in this case, would be y equals 0. So to graph, we're going to look at our equation. We need to put it in standard form. Standard form is one of these two up here. We notice that this is a y squared problem. So that means this equation, or this graph of this equation, is going to open up right or left. We're not sure if it opens up right or left yet, but it does open up to the sides because it's y squared. To figure out our focus point, we see that the equation is y squared equals 4px. The 4p represents the 20. So we like to come in here and say that 4p equals 20, divide by 4, and the p is going to equal 5. So if the p equals 5, it's a positive number, so our focus is going to be 5, 0. Notice that the p goes first whenever you have a y squared. Y squared means it opened up sideways, and the focus has to be moved to the right, so it has to be an x value. Your directrix is going to be x equals -5. You can look at the chart and see that that's going to be x equals the opposite of your p. And your axis of symmetry is still going to be y equals 0. So we know that we're going to have our vertex at the origin, because there's no translation, no parentheses. There's no translation for this one. Our focus point, 1, 2, 3, 4, 5 over, so that's our focus point. Our directrix is over here. It's not an asymptote, but we draw it kind of like it is. We label that x equals -5. So we're looking at all the points that are equal distance from here and our directrix. One of the easy ways to do it is to plug in a few points. When picking points for your parabola, we know that this is going to open up to the right because we have a positive 4p. So we're going to pick values for our x. Our x, we could pick 1, 2, 3. You could even pick 4 if you wish. That might get a little big. When we plug in 1 to our equation, we're going to get 20. So the square root of 20. We type that into our calculator, and we get 4.47. When we plug 2 into our equation, we get 2 times 20, which is the square root of 40. And the square root of 40 is going to be 6.32. Plug a 3. 3 times 20 is 60. So the square root of 60 is 7.75. And just the last one for fun would be the square root of 80. That comes out to be 8.94. So now we can plot those points. Remember, when you take the square root, you really get a plus or minus value for all of these. So we're at, when x is 1, we're going to be up at positive 4 and almost a half. And almost negative 4 and a half. And then at 2, a little bit over 6, and a little bit past negative 6. And our parabola is going to follow that same pattern around, and we always label our equation. So this is y squared equals 20x. We're going to start out with our equation. Y equals -1/4 x squared. This is not in standard form. Standard form has to have the variable squared by itself. So to get that by itself, you have to multiply by the denominator. In this case, we could multiply by a -4. So our standard form is going to be x squared equals -4y. So now we know our equation is going to be opening up or down because it's x squared. It happens to be opening downwards because we have a -4p. To figure out our value of the p, we know that this -4 has to equal the 4p of the equation. So we divide by our 4 and we find out that the p value is -1. So 0, -1 is our p value. Y equals +1 is the directrix, and the axis of symmetry is the y-axis, which is x equals 0. So now we're going to plug in some points. We know our vertex is at 0, 0. We have a focus point at -1. 0, -1, and we have a directrix at y equals +1. We're going to pick values for the y and then take the square root of that. Recognize for us to take the square root of a value, the value has to be positive, and the only way we can get -4y to become a positive value is to pick negative values for your y. If your graph is going to open down, of course, those are all negative y values. So -1, -2, and we might as well just march our way through. So when we plug in a -1, we're going to take the square root of +4, which gives us a ±2. Take the square root of 8, which gives us a ±2.8. We'll take the square root of 12, which is ±3.6. And we can take the square root of 16, which gives us a ±4. So when y is -1, we're going to be at +2 and at -2. 2.8 and out at 4. And our equation is x squared equals -4y.